The basic approach of object-oriented programming is to think in objects. For example, a special booking with all the attributes and their special functions, which work only on those attributes. The technical description of an object is given by its class, and the object is an instance of a class. Each object exists only during the lifetime of the program. A class consists not only of object-dependent descriptions, but also components which are valid in general and have no special dependence on a concrete object. These components are called static components, that is, static attributes and static methods.
An interface is a collection of formally defined methods without any coding. Formally defined methods refer to the names of methods and their signatures. An interface can be integrated with a class, which is then known as the implementing class of the interface. In the class, you can implement all interface methods with their class-specific implementation. If you have several interface implementing classes with their class-specific coding, you can have only one method of definition in the interface, but several different functionalities in the implementing classes.
Instances are created during runtime and therefore have no name. This means you have to call an instance over its reference variable, that is pointer, which refers to the instance. You must define a reference variable in the declaration block of a program with the additional specification reference to class. This means that the reference variable appears during runtime to a specific instance of this class, which is not yet created. It does not mean that the pointer points to the class, because a class is not anything physical. It is just a type description. To create an object of the class, use the defined reference variable. The reference variable then refers automatically to this object. You can then call instance components of the object by using the reference variable as a prefix. To call class components, for example, class methods, you do not need an object because the class components are independent of any object of this class. For example, the class prefix is used to call a class method.
There is no way to instantiate an interface because interfaces do not have any coding. Therefore, you cannot use the statement create object to a reference that is defined to an interface. The implementation of an interface is given by a class, which is hierarchically under the interface. So a reference that is defined to an interface is able to refer to an object of the implementing class. Interface references can call only the interface components of an object of the implementing class. It depends on their static type definition. The function then runs in the context of this implementing class. So, if you have several implementing classes of an interface, you can use the same semantic to call an interface method for the objects of these classes. However, a different function runs for each object. BAdIs take into account the changes to the software delivery process. The upper section of the figure displays the typical delivery landscape. It no longer consists only of a provider and a user. Instead, it can now contain a whole chain of intermediate providers. The lower section of the figure explains how BAdIs function. An SAP application program provides the enhancement option. This requires at least one interface and a body class that implements it. The advantages of this concept are as follows. A body is reusable. A body can be implemented many times. even by parties further toward the end of the software delivery chain. A body enables each party in the software delivery chain to offer enhancements. A body contains the components of an enhancement. Each body can contain the following components. Program enhancements. You define the interfaces for program enhancements in the form of interface methods in a body. You use this interface to implement the enhancement. The SAP program calls the interface methods of the generated body class. Menu enhancements. You can enter function codes in a body. These menu options are available in the GUI definition and made visible when the body is implemented. Screen enhancements. You can define and implement screen enhancements in a body. The components created when you define a body are as follows. Interface, generated class, that is, the body class that implements the interface. The generated class, that is, the body class, performs the following tasks. Filtering. If you implement a filter-dependent body, the add-in class ensures that only the relevant implementations are called. Control. The body class calls the active implementations.
The figure shows the process flow of a program that contains a body call. You can see the possibilities and limitations inherent in BAdIs. You must declare a reference variable that refers to the body interface in the declaration section. An object reference is generated in the first step. This replaces the service class CL_exit handler provided by SAP and generates the conditions for calling methods of program enhancements. When you define a body, the system generates a body class, which implements the interface. In the second step, the interface method of the body class is called. The body class searches for all the active implementations of the body and calls the implemented methods.
The figure shows the syntax with which you can call a body. The numbered circles correspond to the calls from the previous figure. You must first define a reference variable that refers to the body interface. The name of the reference variable does not necessarily have to contain the name of the body. In the first call, an object reference is created, which creates an instance of the generated body class. By using this object reference, you can contact only the methods of the interface. You can then use the object reference to call the required methods available with the second step.
You can search for bodies in the following ways. You can search in a relevant application program for the CL_exit handler string. If a body is called from the program, the get_instance method of this class must be called. You can then reach the body definition using forward navigation. The definition also contains documentation and a guide for implementing the body. You can use the application hierarchy to restrict the components in which you want to search. Start the repository information system and choose Enhancements, Business Add-ins to start the relevant search program. You can use the entries in the relevant customizing component. The assignment of the extendable attribute is subject to several restrictions. The domain to which the extendable filter type refers must have the following properties. The domain is linked to a cross-client value table. The value table has exactly one key field which has the data element of the filter type as its field type. The domain has a text table with two key fields. A key field has the filter type as its field type, and a key field is a language field. To mark a field as a text field, the field must exist in a table that contains text or txt as a partial string. In the ABAP dictionary, the text table must be assigned to the value table. The delivery class of both tables must be E or S. Not all filter values that you created in the context of an extendable filter-dependent body must occur in the value field. When you save the data, the system adds these filter values to the value table. When you delete the implementation or the entire body, the system removes the values from the value table. The same situation applies to the text tables.
A default implementation is executed whenever no active implementation of a body exists. The enhancement provider can create a default implementation. To create a default implementation, in the body definition, choose Go to Default Code. The system automatically generates a class with a predefined name. You need to implement the methods for generating the required default behavior. The enhancement provider can also create a sample implementation, which acts as a template that can be inserted in the methods of the implementations as an initial code proposal. To create a sample implementation, choose Go to Sample Code. The system creates a class that implements the methods of the interface. The user can view the sample code as a template.
BAdIs are a logical evolution of the conventional enhancement technique. They have taken over the administration layer from customer exits, along with the availability of the various enhancement components. The idea of making BAdIs reusable was adopted from business transaction events. You implement BAdIs using a consistent object-oriented approach.